video. So today's 35th video will be discussing about functions which are virtual and also abstract classes. But before we get into our topic today, I would like you to watch the 34th and 33rd video. And if you haven't watched it, there's a card on the top right corner. So if you haven't watched it, click on the card and watch that right now so that you can understand what virtual functions are. Because virtual functions are going to be needing some concept of what function overriding we gave in the last video. So apart from that, a virtual function is a member function in the base class that we expect to redefine in derived classes. So it's basically a member function. We know it's a function in a base class, and it is just declared within base class and is redefined, and it's basically overridden by the function overriding methodology. So that is applied and it's overridden by the derived class. It's outtaken, it's replaced by the derived class. So you might ask, why would we even do such a thing? But there are so many reasons to do why, and I would explain it more better when we go in our programming example. So basically, a virtual function is used in the base class in order to ensure that the function is overridden. This especially applies to cases where a pointer of base class points to an object of a derived class. So what we do is we cannot even instantiate an object from the base class anymore because now we have a virtual function into our base class. So that class is no longer a base class, a formal base class. It would be defined as an abstract class. And what an abstract class is, it's a class where there's a virtual function. So an abstract class is a class that is designed to be specifically, sorry, let me say that again. An abstract class is a class that is designed to be specifically used as a base class. And abstract class contains at least one pure virtual function. So if you have one or more than one virtual function in your base class, your base class is known as an abstract class. A class derived from an abstract class. A class derived from an abstract base class will also be abstract unless you override each pure virtual function in the derived class. So if this doesn't make sense, it will make sense when I write the code. So when I write the code in the dev C++, or you will see some example problem, it will be more easier for you to understand. So this is basically, purpose of this is to achieve runtime polymorphism, and functions are declared with a virtual keyword in base class. So let's jump into our dev C++ without further wasting our time. So hash include IOStream and using namespace standard. And I have some code written already for you, and I would just explain what I've wrote. So you could see over here that I've included my boilerplate, which is on the top. And then after that, you have a base class defined over here, and I also have a derived class which is defined here, and then I have my main logic, and there's something going on into it. So what happened over here is my first class is known as my base class. So my base class has a public section, and in the public section there are two member functions. One is show and one is virtual show. Okay, so what is this virtual print function? This is how our virtual function will work. We'll basically write our function like, for instance, it's just a regular member function, but before or prepending it, we would use the keyword virtual to it, and this will allow us to know that this is a virtual function which will be doing some operation on this. So base class show function called is printing through this show function, and base class print function called through this print function. It's straight as forward. Whatever we're doing, it's showing, and it's really intuitive. A class myDerived is basically being derived from inherited publicly through the base class. And if you don't know how to do this, I would recommend watching my inheritance video. You could see a card popping on the top right corner. So after inheriting it publicly, you would see that these member functions are now also included over here. And now what you could see here is that these are both the same. So function overriding is being taken in place, and what's going to happen is that the show class and also, the show member function and also the print member function are going to be in here. So the question arises, why is this virtual going to do? So there's going to be a derived class show function called and derived class print function called. Now, after that, we will know why this virtual is even used. So in the main function, you could see over here, as I said during the definition of virtual functions, you have to basically you cannot instantiate of an abstract class. Now this class over here is now an abstract class. Why? Because according to the definitions, it has a virtual function. So we just call this as an abstract class. And over here, we could see over here that my base is a pointer. So pointer to my base, and now this is the base pointer. Now base class pointer declared. So I would just space that, and you can see that a pointer is declared. Now what we could do is over here, if you don't know how to use pointers, there's another video that I've explained extensively how to use pointers. So you could define it anywhere you want. It could be in the center. It could be over here. But conventionally, I use it right after defining my identifier name. So I like using that. You could adopt the other method. Anyways, my derived object. So we created a derived class object created over here. So we have a derived object and we have a base pointer. Now what the base pointer will do, it's gonna use the derived object and it's using its memory. So it's going to assign it to its memory. And now you would see that the base pointer pointing to address of derived object. So this base pointer is pointing to the address of derived object. Right now, you would see that the runtime polymorphism is going to be taken in place by base pointer and this operator. And you would see the print function being called. Now the print function, we know that the print function over here is virtual. So which function is going to be called? That's a question. And then after that, base pointer, and then this pointer to show function. Now we have two show functions. Which is it going to be called? So let's have a guess. Now we know that it's a virtual, and we know that virtual functions are not going to be allowed. So basically, we're going to be allowed to use this. This is going to be overridden by this. So we're going to have this function being displayed. So basically, derived class print function called in this case. We would say derived class. And over here, show function. So over here, we have a base class. So because we don't have virtual function here, this one is not going to be overriding, and we'll have this one as instead. We'll just copy this, and we'll just paste it here. So base class show function code. So let's see if our guesses were right. So I would execute, compile and run, and let's see. So we have derived class print function called. If I would go over here, you would see I said derived class print function called. So first is correct. Base class show function called, and that is also correct. Why? Because over here, derived class, you could even know that it's a base pointer. The complexity that could occur is that you created a base pointer. So why not having the base member functions being called? Now the virtual function comes into play and it will override it. And then basically this will be printed instead of that. So if I do not include this virtual keyword, I'm going to have this instead. I will have only this instead. I would have base class of both of them called. So if I do that, I would execute, compile and run. And you would see base class print function called and base class show function. So I'm not having any of the derived class being called. Why? Because I don't have the virtual keyword over here. So I would replace it by the virtual keyword. I would save it, and now you would see instead of this calling, this will be ignored and this print function will be called. So execute, compile and run. Okay, so this is base class and this is derived class print function called. So that was it with this video about virtual functions and abstract classes. We reached a conclusion here, and now that was it with the video. If you would like to see a more complex version of this kind of concept, please let me know in the comments section. And without further ado, I would like to conclude. Make sure to subscribe, and we will see you in the next one.